Hi, geometry students. It is day 1-9 notes, and we're doing more with triangle relationships. So the very first thing is the extra properties that an isosceles triangle has. So you've got this little diagram written right here. Let's label it up with a couple important things. So when it is isosceles, that means that we have two congruent sides. It's a little dark in here. You can tell lots of shadows as I'm writing. All right, so the two sides that are congruent, in this case, I'll use the two that actually look the same. And then we have the angles that are opposite them that have equal measures. And that's based on the fact that, when you think longest sides across from the biggest angle, and vice versa. So if the angles are the same, then the sides are the same. All right, so we can say here that the angles opposite the equal sides are also equal. And these are referred to as the base angles. Right? So this is the base of the triangle, and therefore here at the bottom, these are the base angles. The top here is referred to as the vertex. So if you hear a question where it says, in an isosceles triangle, the vertex is this, find, the base angles, that's what they're talking about. So with this next one, it says, if we have triangle ABC and side CA and CB are congruent, here's the measure of angle A, find C. I would always suggest just draw a little diagram. It could be pretty quick and easy. Because it says CA and CB are congruent, I would put C up at the vertex and then A and B. If for some reason you drew C down here, then these would be the two congruent sides. It doesn't always have to be that the top is the vertex. It's just typically the way that we draw it. And so sometimes our brains, just default to that setting there. If these two sides are the same, then the angles opposite are the same. So when the measure of angle A is 50, that means the measure of angle B also 50. To find the measure of the top angle, then we're using the triangle sum. So they all together add to 180. 50 plus 50. Take that away from 180. And there's our answer. 80 degrees for the measure of angle C up top. All right, the next question. You've got the diagram given to you already. So triangle LMO is isosceles with LO equal to MO. On your picture, mark that. LO congruent to MO. There we go. At the bottom, measure of angle L is 55. The measure of angle NOM is 28. Both of those are already marked. What is the measure of angle N? Ultimately, that is what we are looking for then, this guy over here. I would start by marking all the things that we know within the isosceles triangle. Here's my congruent base angles. And maybe I even want to show them a little different than that guy. If this is 55, so is that one. Now we can work from there. And you have an option. You could either find the angle next to 55 because they're a linear pair and then work your way over here. Or you could find this top angle and use the bigger triangle to find that remaining part. Either one's perfectly fine. I think I'm going to use the first idea of saying that we can find this angle measure because these two together form a straight line. So 180 degrees minus 55 should be I want to say 125, but I'm afraid I'm making that up. Minus 55 should be 125. There we go. And then I can use this triangle to find my answer. So 28 and 125. That'll give me, there we go, 153. 180 minus that 153 and 27 is that final remaining angle right there. So you might want to use a combination of different properties. So we used isosceles, we use linear pair, the fact that they're supplementary, we use angle sums in a triangle add up to 180, all sorts of stuff. All right, this next question, there's a lot going on with this next one. It says in triangle ABC, they give you the measure of angle A in terms of x, B in terms of x, C in terms of x. Determine if the triangle is scalene, isosceles, or equilateral. We know what those three things mean. Scalene, no sides are the same. Isosceles, two sides are the same. Equilateral, all three sides are the same. We can determine that based on what the angle measures are. If the angles are the same, if two are the same, or if they're all different. I would start by just giving yourself a diagram to work with. So if we say, okay, here's A, B, C, label those angles. 8x minus 4. We've got 21x plus 3 and 6x plus 6. The fact that we have three interior angles, I'm going to use the triangle sum property. Add them all together and set them equal to 180. It takes a little bit of work to combine and clean things up. 21 and 8 is 29, plus 6 should give us 35x, minus 4, plus 3, plus 6. It's either mental math or you're grabbing your calculator. So I end up with plus 5. Move that on over. We get 35x equals 175. Ooh, and this one comes out nice and pretty. So x should come out nicely as 5. From here, to be able to finally answer the question, though, you have to be able to figure out what the angle measures are. So plug back in. Plug back in. You should be able to find what angle A is, what angle B is, what angle C is, and then ultimately decide, is the triangle scalene, isosceles, or equilateral? That is going to be the post-video question. So finish this guy up so that you can answer anything I ask about question 3 there. Moving on to the next page, we have some vocab that we need to talk about. The first thing being called the median of the triangle. You may be familiar with that term when you think like mean, median, mode. This is a different type of median, but still sort of similar to when you think mean, median, mode. Median in those terms meant like the middle number. Median here means a segment that connects to the middle of the opposite side and a vertex, or I should say from the vertex to the middle of the opposite side. So let's get that written out first. It is the segment that connects the vertex of a triangle. I'm going to cheat and just draw a triangle there, to the midpoint of the opposite side. So that's where that middle context still holds true. So the segment that connects the vertex of a triangle to the midpoint of the opposite side. Now, technically, there's 3 medians, but it's sometimes easier just to think of it as being one first. So I'm going to use B as my vertex. And right now, just eyeball where the middle of the opposite side is. And I'm going to just label that as my midpoint. I don't really need to give it a fancy name. If I connect from B to that midpoint, that segment is called the median. So you can reinforce that that's a midpoint by marking those 2 little parts congruent. And let's add a couple more details. I do want you to note that every triangle has 3 medians, 1 drawn from each vertex. So I could draw one from A over to side BC and from C over to side AB. And then when we talk about proofs with this, I'll write it over here. If you are told that something is a median, what that is going to mean for us is that we can say a median implies we have a midpoint. because if that's a median, I know that that's a midpoint here. And then in the next step, we'll be able to say, well, what does a midpoint mean? Well, a midpoint is going to tell us that we have two congruent segments. So when we start putting proofs together, one step should flow to the next and to the next. So knowing we have a median would tell us this is a midpoint. Knowing this is a midpoint will tell us those segments are the same. So you can kind of see the reasoning or how it flows together. All right, how we use a median, in an example here. We've got, let me see if I can zoom in just a little bit. We've got triangle DEF, and a median is drawn from vertex E to side DF. All right. So something to keep in mind. If I say here's, DEF, a median is drawn from E to side DF. So just to show you that it doesn't have to look exactly the same as the last one. It can go from a corner up to the side versus the top down to the middle of the bottom. It says call the point where the median intersects DF, point P. All right. If the segment DP is equal to 4x minus 1, and if FP is 5x minus 4, find the length of DF. So that's the entire thing here. All right. What we want to take away from this, median means we have a midpoint. So that means that P is the midpoint. And if I have a midpoint, then I have two congruent segments. So that little segment is congruent to that guy, which means we can set dP equal to PF and be on our way here. 4x minus 1 equals 5x minus 4, and solve. The solving part of this is really quick and easy. I'm going to multitask my steps here. And I end up with x equals 3. The final says find the length from D to F. So if we have x, just like the question I kind of left you alone on the front, you would just plug back in. So dP is 4 times 3 minus 1. 12 minus 1 would give me 11. If we did this correctly, P to F should be the same thing. So 15 minus 4, yep, that'll be 11 as well. And then put it together to get the length of DF. So 11 and 11, that gives us 22. Oops, and I'm just off the page there. There we are. So median is sort of an extra segment, but it also could just be a roundabout way to give you some information about a particular segment, just expecting you to know that much more. All right, that is not all. You have one more vocab term. Let me zoom back out a little bit here. And that is called an altitude. So when you think of like mountains or, if you go hikes, maybe you guys did that during some quarantine possibly. The altitude can also sometimes be referred to as just the height. Right? So if you're at great heights up in the mountains, we talk about like the altitude up there. In a triangle, it specifically is the segment that connects the vertex of the triangle perpendicularly. That's a big word. Perpendicularly to the opposite side. Right? Which is just code for it forms a 90-degree angle. So let's see if we can reason our way through that. Let's use vertex B again, just like we did last time. We're going to draw that segment and connect it to the opposite side, but perpendicularly, meaning forming a 90-degree angle. So do the best you can to drop it straight down and form a 90-degree angle right there. I'm going to call that point D, because it's not a midpoint. It's not any special point per se. And then that segment is the altitude. Try to get that drawn in there. So what we can say over here is that AC is perpendicular to BD. That's that notation for perpendicular there, that upside down T. Couple things to keep note of. There are 3 altitudes in every triangle. And sometimes the altitude is going to fall on the outside of the triangle.
Okay, hello.
So when you draw a median, because you connect it to the midpoint, it will always fall on the inside. Just to show you a quick sketch, if you have an obtuse triangle like this, and then you draw the altitude, to make it perpendicular, I can't draw it at this steep angle. I would actually extend the side of the triangle, and then I would draw the altitude straight down from there. That would be the altitude. So it can fall on the outside of the triangle there. In terms of proof speak, so for proofs, if you are given that something is an altitude, we are going to be able to say that we have perpendicular lines. So it's kind of a different way to give you that information. So median is going to imply that we have a midpoint, and altitude will imply that we have perpendicular lines. So like up top, AC being perpendicular to BD. All right. The very last one here, I'm thinking maybe we'll save this for a recap for class. So hold tight onto that guy, and we'll go over it when I see you next. All right, guys, have a good one.